everyone, and now it's time to try out example 9-8. There we go. So in this one, I'll read it out to you and then we'll draw a picture because it doesn't come with one this time. So a 100-foot long steel bar suspended vertically from its upper end. I'm going to go ahead and draw that. So we got a 100-foot long bar. Definitely looks like this. And supported from its upper end. This doesn't move. The cross-sectional area of the bar is 4 inches squared. Okay, so A is equal to 4 inches squared. Perfect. The unit weight of the steel is 490 pounds per cubic foot. Ooh. Okay. Weight is equal to 490 pounds per foot cubed. And once it's defined, the maximum tensile stress due to the bar's own weight, and the maximum load that it can be safely supported at the lower end of the bar if the allowable tensile stress is 24,000 psi. So, given length is equal to 100 feet, area is equal to 4 inches squared, weight is going to be equal to 490 pounds per foot cubed. And once it's defined, the stress just due to the weight and also the max load it can hold if the stress is going to be equal to 24,000 psi max. Okay, there's a lot to do here, but it's not as hard as you might think. The first and most important thing that we have to think about is this, the weight. This is 490 pounds per foot cubed. Don't let that confuse you. 490 pounds per foot cubed. So, first things first, we should probably convert this a little bit. Per foot cubed is kind of weird, but it's a long beam. So let's figure out how much it is per foot. So, let's see right here. What would be the best way to do this? Well, we have the cross-sectional area right here. We can do that. And so what we could do is we can multiply this value we have right here by the area to get the weight per foot if we wanted to. So let's try that. So we're going to make this thing called weight per foot. And it's going to be equal to the weight per volume. Sorry, that should have been a V. Weight per volume times the area. So we write this down, and that comes out to be 490 pounds per foot cubed times 4 over 144 inches squared, and that'll be feet, which comes out to be 13.61 pounds per foot. Now, you might be wondering, where did this come from right here? Well, I just converted it from inches squared to feet squared because I have feet cubed right here and I want to get to pound per foot. So I need to multiply it by feet squared. So the 144 inches squared is simply that there is 1 foot is equal to 12 inches. So if I square that, I get that 1 foot squared is equal to 144 inches squared. So that's where the number comes from. Okay, now back to our weight per foot. If we do that, we calculate it, we get 13.61 pounds per foot, which is 100 feet long. So we multiply that by 100. We get that the total weight is going to be equal to the weight per foot times 100 feet, which is going to be equal to 1,361 pounds. That's a heavy bar. I do not want that falling on me. But that's just the weight. That's not enough to solve our problem. Okay, now I'm running out of room here, so I'm going to erase our givens for the moment to give myself just a little bit more room to work. Now, first off, it asked, what is the stress due to just the weight? Just the weight, nothing else. Well, that stress is going to be equal to the load over the cross-sectional area. In this case, the load is going to be equal to the weight. So the stress is going to be equal to the weight over the area, which is going to be equal to 1,361 pounds all over 4 inches squared, which will be equal to 340 psi. Okay, that one was a bit easier. The second one isn't honestly that hard either. It says, what is the max load it can take if it can only support 24,000 psi before it breaks? Okay, now you might be wanting to jump in and say, okay, well, my stress is going to be 24,000 psi, and we can do that, but we got to remember that whatever load we get at the end, we got to subtract out the weight. So let's do that. So first off, stress is equal to load over area. And just to make it completely explicit, I'm going to rewrite this as my P allowable, or let's see, make sure this is right. Yeah, P allowed plus the weight over the area. So I've got this load that's allowed for me, and I have to add the weight to that to get my overall stress. Okay, I know what the weight is, I know what the area is, I should be able to solve this. So what I get is that 24,000 psi is equal to P allowed plus 1,361 pounds all over 4 inches squared. And if I solve correctly, I get that P allowed is equal to 94,640 pounds. So it can hold a whole lot. This is one of those things you have to be careful about though here. When it's saying the allowed load, you can't forget that the weight is a part of this. You cannot forget that both of these things are part of that load that was going into our stress. Be very, very careful about that. Another way we could have done that was just to simply take our allowed stress and subtracted off the stress due to the weight just to start. And that would have done effectively the same thing. Then our load would have been exactly what we just calculated. We would have had to worry about adding the weight to our load to solve. Okay, so I hope this made sense for you, and I will see you in the next example. Have a good day.